What's the difference between deterministic gradient and stochastic gradient? Let's start with a cost function or loss function j. That's a function of theta. The loss function L is a function of x and y. X and y are data. That's why we use the subscript I that goes from 1 to n. That means the sample size. Theta is a vector of parameters. Remember, in a neural network, you might have millions of thetas. Because we want the optimum theta, we take the gradient in respect of theta. We call this deterministic gradient because you are using the whole sample, the whole batch, sample size n. That means you are using the whole training dataset of sample size n. Deterministic gradient is a great idea for simple models like ordinary square and log and probit. However, for deep learning and many machine learning algorithms, this does not work. For example, in deep learning, usually you have to optimize a function that is not convex and it has millions of parameters. That means that the deterministic gradient is too expensive computationally, even for a high-end computer and a high-end GPU nowadays. Then the dominant way to minimize the loss function is to use the stochastic gradient descent. In the stochastic gradient, instead of using a batch of n, you use a mini batch of sample size m. Mini batch is typical power of 2 because it helps the GPU to do the computation. For example, using 2 data points, 4 data points, 8 data points, 32, 64 data points, and so forth. See the equation below. G is the stochastic gradient. It has the same formula of the deterministic gradient. The only difference is that instead of using sample size n, you are using sample size m, that is a mini batch, instead of a whole batch. These mini batches are random extraction of the whole training data. Then, when you get enough extractions to cover the whole training data, we call this epoch. Epoch means each iteration over all the training data. Usually we run several epochs, but we run the risk of overfitting. See an example of a stochastic gradient descent. We start at the point t equals 0. Then the computer extracts several mini batches from the training dataset. Then the computer calculates the gradient for each mini batch and averages over all these gradients. Now we know what direction we have to move to minimize the loss function. Then we move to the right, one step to the right. And then we do the process again, moving to the direction where the loss function is minimized, until we get to the point t equals 3, that's the minimum point. Formally, what we are doing is describing the equation below. We update the parameter theta based on the previous value of the parameter theta minus the gradient. But see that you multiply the gradient g by the letter epsilon. Epsilon is the learn rate or step. If the learn rate is too low, it gets too long to get the minimum. However, if the learn rate is too high, you can overshoot and pass the minimum. Then you have to return back, and it might never converge to the minimum.